All right. Hi. Welcome, everybody. Let's talk about guidelines. My name is Arne Mertz. I'm a software engineer at C Core Engineering. We do mostly contract work for all kinds of companies. I'm mostly working on embedded projects, but not exclusively. I've been working with C++ for about 2 decades, but this talk is explicitly not entirely C++ specific, so it's more general. If you're looking for code, you really have to pay attention because I think there are 2 slides with code and the rest is not really about code. It's about guidelines. And on the side, I'm a trainer for C++ and for all things maintainable code, clean code stuff, unit testing, and so on. In my 9 years at Circle, I've worked in about 12 projects for different lengths, sometimes just a few just a few months, sometimes multiple years, and different industries, different environments. But all these projects had one common baseline. They had some kind of style guide, guidelines document, something in that area. Often provided by our customers, sometimes provided by the project team, which could mean either a team completely from our company or a team mixed developers from the customer company, from us. So it's really quite different. Those documents are usually more or less closely followed. So in some projects, there is a guideline document, everybody ignores it. And some projects you have to stick to the guidelines, right? And these documents are, at least in the last years, quite often inspired, motivated by the C++ core guidelines. Let's do a quick warm-up. This is not a guideline. This is a proverb, right? Who has heard of this? Jack of all trades, master of none. 1, 2, 3, 4, a couple hands. What does it mean? So a common interpretation is can do everything, but nothing really well. So not really something good, right? Is that the actual meaning of the original proverb? Hint, it's not. The full proverb is jack of all trades, master of none, but oftentimes better than master of one. Interpretation, we need generalists. I learned this in my very first project at Silke, where I came and said, I do want to continue doing C++ because that was what I had done before. I want to get out of all the insurance stuff, which I had done for 8 years before. So naturally, my very first project at Silke was insurance stuff in Java, JavaScript, web development, so no C++ at all. So I was the master of one of C++. So I did everything else, but what I actually could do. So I was the journalist in the project because we had people doing JavaScript, we had people doing Java way longer than I had ever done. So I've learned all these things on the project, but I was a journalist. And after a year or so, our project lead called me the Swiss Army knife developer. So basically, if there's a problem and nobody wants to solve it, just give it the journalist. So depending on the size of the team, we need journalists. I mean, if you're a one-person team, that's obvious, right? If you have 200 developers, maybe you don't need a journalist, but in small-sized teams, 5, 6, 7 people, you usually need one of these. So, what am I going to talk about? We're going through a couple of guidelines that I've seen in projects, not only at Silke, sometimes from before. I tried to figure out where they originated from, what the impact is of the guidelines, how we found them in the projects, and what we can learn from the differences between the guidelines, how we found them, and their origins. And then some guidelines, disclaimer with my opinions about guidelines, how to deal with guidelines. First guideline, C++. Define or delete all copy, move, and destructor functions. Rule of 5. How does it sound for you? I see a shaking head. Anyone else? Good? Nah? Core Guideline C21. If you define or delete any copy, move, or destructor function, then define or delete them all. Tiny difference. Even more important, C20, which comes before it. If you can avoid defining default operations, then do. Major difference, right? So slightly, it sounds similar, but it is completely different. So what's the impact of having this kind of guideline in the project? It leads to needless boilerplate because people start to write the usual 5 everywhere. I've also seen a rule of 6, which includes a default constructor. So they try by force to have like default constructible objects, even if they shouldn't be default constructible. You write sometimes needless non-trivial members because I have seen people who say, well, I have to write a copy constructor, right? I don't want to delete it, so I write it. Manual member-wise assignment. Maybe skip a member, but these are then non-trivial copy constructors, while otherwise the compiler will generate trivial copy constructors for you, which can turn out to be quite more performant. And the wrong boilerplate because, well, it's the 5th class I'm writing today. I just write the same thing. I copy paste maybe and just rename the class name and stuff like that can lead to errors. Another thing, this is the rule of 5. We were talking about guidelines, right? So, quote from Pirates of the Caribbean. It's more what you call guidelines than actual rules. So there's a difference between rules and guidelines. And it's an important difference. Developers usually love rules. They're very strict, they're very clear. We don't have to really think, we just follow the rules, right? We're used to having rules because our compiler is very strict as well. If the compiler says no, then, well, we can't argue with it, right? So we have to follow these rules. And, well, often many rules, most rules can be checked automatically because they are that strict, right? Guidelines are less strict. So there are exceptions to the guidelines. There are areas where the guidelines don't apply and maybe we have reasons to not follow them. We have more freedom to either follow them or not, but we also have more responsibility. Guidelines are formulated like avoid something, prefer something, consider something, while if I would write this as a rule, which I probably should have, don't interpret guidelines as rules. Okay, prefer to follow the guidelines, but think about whether they apply, right? And please do provide comments when you break the guidelines and write why you didn't follow the guidelines. Because the people after you who read it and see, why didn't they follow the guidelines here? They will thank you for it, right? So please don't do this. Stick to the one in the core guidelines, maybe have a link to the core guidelines and stick to that one, but don't simplify this guideline or the rule of 5. How about tooling? Many guidelines, who has been in the talk in the keynote this morning, many guidelines, especially from the C++ core guidelines, can be checked by Clang Tidy. There's a huge set of guidelines that can't be checked because they're more wishy-washy, not really specific. But many can be checked. But if you have this tool enabled to check for the rule of 5, do you actually need the rule of 5 in your guideline document? Maybe, maybe not. Another guideline found in the wild. don't use exceptions. This is different. I work in embedded from we can't use exceptions because we are working on a tiny chip there where there's no place for the exception stack and stuff like that. The guideline that says don't use exceptions. Who has seen this one? A handful. I've seen it like half a dozen times or more over the years. When you ask people, how do you get to this? Where does this come from? Google style guide says, we do not use exceptions. Difference, we do not use exceptions at Google, not don't use exceptions. Then if you read the fine print after this, Google has a lot of code. A lot of code is written without exceptions in mind. And if you were to introduce exceptions, then you would have to basically fortify all the code against exceptions that can be thrown, make it exception safe basically. And that's not feasible for the range of code, for the large code base that Google has. So they say, we cannot use exceptions. Our advice against using exceptions is not predicated on philosophical or moral grounds, but practical ones. So it's just not practical to use exceptions. This is not that we don't like exceptions. Things would probably be different if we had to do it all over again from scratch. So this is a hint they would like to actually use exceptions. Not we hate exceptions, don't do it, right? I've given this talk once before, and after the talk I had someone coming up to me, yeah, I worked for Google for a while, and we were actually in a project where we were using exceptions. So this overall guidelines for which makes sense for the large, big Google code base does not apply to all of their parts. And everyone I talked to about the don't use exceptions guideline, yeah, Google says it. Google are the cool kids, so we have to do it as well. Are you Google? Do you have this kind of code base? Probably not. Maybe. There are teams that have like big code bases that are not aware of exceptions, and then they can't use exceptions, right? What's the impact? Well, exceptions are a part of the language. Who likes exceptions? Who does not like exceptions at all? 1, 2 people, okay. They have to be handled. If you don't, then your program terminates. They can be handled where actually you have all the information that you need to handle them. You don't have to propagate them manually from function to function to function to function until the place where you can handle them. And not using exceptions affects basically the whole code base, right? You have to basically use either your return channel is used and you have to use out parameters, which I see quite often, which is ugly to reason about because you see something pass into a function, but it's not actually an argument, it's the outcome. Or you have to use stuff like std expected, std optional, std variant, stuff like that. And you have to test that your error propagation that you have in your function actually works and does the right thing. Whereas when you call it, when your function just calls something that might throw an exception, then it just does the right thing. It propagates the exception and the compiler guarantees that it works. So for guidelines, the context matters. They are quite often not universal. Many things in the core guidelines are, but guidelines that you get from other locations may be specific to that location. So depending on what project you are in, what team you're working in, guidelines may or may not apply. The same is for rules. Like there are maybe strict rules for specific applications, for specific areas of application where you basically have to follow those rules. But if you don't work in those areas, those rules don't apply to you, right? So please don't use this guideline except unless you are Google or you are in a Google-like code base where you really can't use exceptions. Next guideline. Every function shall have a single return statement. SESE, whatever that means. Who has seen this one? Couple of hands. Okay. I tried to figure out where this came from because I didn't agree. The function shall have a single point of exit at the end of the function. Misra C, P. Reasons stated in those documents: readability, and it avoids leaks. My counter-argument: if we use early return and guard clauses, they are a relatively common pattern that can improve readability. I don't have to like nest if aces, if else's and stuff like that. If I say, okay, my conditions are not met, return, done. Another condition is not met, return. And then I do like 5 lines of my actual processing, and then I have the actual good case return at the end of the function, which is okay. In C, the argument of leaks, I can completely agree. If you have stuff where I have like pointer where I allocate memory, I have to think about deallocating this memory. Then I probably want to do this like in a cleanup block at the end of my function, and I don't want to have an early return where I risk leaking the memory I've allocated before and stuff like that, right? I've seen patterns where they just have like, if something goes wrong, then go to cleanup, and then I have like the cleanup block in the end, and then the return. In C, that's perfectly good. In C++, we should use RAI classes like smart pointers, smart locks, all the kind of things we have, so we can use early return and just be good about it. So again, context matters. Some projects have to follow external standards like the MISRA standards and other functional safety standards. It's required of those projects to follow them. This can be in automotive, maybe medical stuff and similar areas, right? If you have to follow those rules, there's no way but to actually follow those rules, even if it makes maybe your code base a little less readable, depending on personal opinion probably. I would, regardless, not repeat those rules in your project guidelines, but instead say in the very beginning, okay, we have to follow this set of rules, look here, and then have a link instead of like repeating all the stuff, copy paste. Regardless, regulations like that, and in those projects, you need a more formal approach. And there are usually automated tools that check these kind of things. So MISRA standards, I know that most, if not all, the rules can be checked by tooling. And then you obviously should use that tooling. And then the tooling should tell you this is not okay, you're violating this guideline. It'll probably give you a link to the guideline instead of you having to look it up in your personal or project space. What about the SE? Means single entry, single exit. I had to dig somewhat to actually find out what single entry means. Single exit, okay. Probably like this one return at the end of the function, but single entry. I mean, you enter the function from the top and that's it, right? Why do you have to state this? Means don't jump or go to or entry, that's a Fortran keyword, into alternate points at the function. This is possible in some languages, to enter a function not from the top, but from somewhere in the middle. Single exit is from don't return to a different point than the one immediately after the call of the function. This is also possible in some languages, that you specifically say, if I'm in this error case, don't return to the call site, return to somewhere else. From what I know, Fortran, and maybe 1 or 2 other languages, but not C++, and also not C. However, in C++, technically, if you throw an exception, we exit the function early, and we end up somewhere else, right? But all the stuff in between still gets the stack gets unrolled by the compiler. So the compiler basically says, yes, you go there, and I implicitly go you back to the catch handler for exception. So under the hood, it's still a single exit. So these single entry, single exit, There is a document written by Edgar Dijkstra, I think in the mid-70s or something like that, where he says, well, your function to be readable, to be understandable, should model this like you have the single point where you enter the function and this single point where you get to when you leave the function. They were not using exceptions back then, but apparently all kinds of go-to come from what else, which made the code unreadable. So this is about that code back then. What's the impact of single entry, single exit, or just one return at the end of the function? Well, pattern that you probably also have seen quite often. I have my red value and I don't know what it will be yet, so I will give it like an empty string or a minus or something to indicate this is like the more or less initialized value. And then I do my pre-checks and I can't immediately return because I only have this one return at the end of the function, so I set some flag that something is not okay. And then I have to endure the rest of the function even though I already know what I will return, right? And the alternative to the is okay is basically invert the condition, and then I say if my proverb is not empty, then I do the next check, and then I do the next check, and sometime I'm completely out of my screen, and then I come back at some point, right? And the very else is like error, I don't know what I'm erroring about because it is 40 lines above. I've seen this, and it's horrible to read. So forcing a single exit in many cases reduces the code quality. This return value dragged from top to bottom till we get actually to the return, instead of immediately, I know what this does, return this. I know what it does in this case, return something else, right? And either this is okay value or the deeply nested indentations. And also, like I said, we can't really use exceptions when we really want to fit to the style. So some of the guidelines are ancient law that has been transported, like this is bad, we shouldn't have early returns and stuff like that. Our languages have evolved, our tools have evolved, our understanding of how to write code has evolved. So question where these guidelines come from if they seem not applicable to you anymore. This includes guidelines for C++ 98 and stuff like that, right? So please don't cite rules that are completely outdated, and when you see them, question them. A guideline found in the wired. Don't use references as members. Who has seen this one? A couple of hands, okay. The core guideline, where this comes from, don't make data members const or references in a copyable or movable type, because they make such types difficult to use by making them at least partly uncopyable or unmovable for subtle reasons. Well, it's not so subtle. If you have a reference or a const member, you can't assign it to it. So copy assignment, move assignment cannot be generated by the compiler, and you have to write workarounds, and maybe they don't really do what you would expect. Instead, use pointers. For example, GSL is the guideline support library, not null if you mean to have a pointer that is assignable but never can be null. And then tools like ClangTie, you can check on that one. The important one is the bold one, right? This means in a type that is designed to be copyable or movable. In those types, you shouldn't have const and reference members. That's correct. In any other types, you can have const and reference members. This type is otherwise copyable except for the reference member. So this is a code randomizer service where you have your repository and you save your used quotes and you have a random engine in there. The vector is copyable, movable. The random engine is copyable, I think also movable. And so except for the reference, this would be copyable. Does it have to be copyable, movable? Not really. It's a service, you construct it once, it sits there until the end of its lifetime. Everybody who uses has a reference or a pointer to it and then uses it, and You never need a copy of this. You never need to move this. So don't make data members const or reference for types that are designed to be copyable and movable, for types that should have value semantics. Quite often you have like this application services, factories, repositories, all these buzzwords from domain-driven design and similar, where you have like these objects that just exist there a couple of times or one time, and you don't need copying and moving, and having reference members in those, perfectly fine. So the reasons for our guidelines matter. So we have to read the fine print. They inform us about when it's okay to have reference members, when it's okay to not, when the guidelines apply and when they don't apply. If you just want to follow the guidelines and say, okay, I guess I have to use not null there, right? It's a bit more verbose and not as easy to read. And in some projects, you have to go through like several layers of bureaucracy to actually be able to use GSL in your code, or you have to re-implement it yourself. Not really fun. Also, side note, which I have seen, don't ignore one guideline just to satisfy another. I've seen people say, okay, I want to use a reference, but my class that I have here is copyable, so I just write the copy constructor equals delete, done, which is against the rule of zero, right? So don't be too dogmatic. Think about where the guidelines apply, where they don't. Next guideline. Const goes to the left of the type, West Const. So let's get out the eggs and tomatoes. Who is against it? Who is for it? Hands up. So who's for West Const? West Const. Who's for East Const? Handful of both. So does it matter to have either one or the other one? A mix is bad, right? But if your whole code base is West Const or the whole code base is East Const, who cares? The actual core guideline, NL26, use conventional const notation. They don't write West Const, they do conventional const notation. So if by C++ 29 or maybe in 10 years, the general usage has shifted to East Const, then this guideline still applies. Then it says use East Const. The reason is conventional notation is more familiar to most, to more programmers, and consistency in large case code bases is important. Absolutely agree. Note, this is a recommendation for when you have no constraints or better ideas. This rule was added after many requests for guidance and after many more issues in the core guidelines GitHub repository that went over pages and pages and pages, because people have opinions about this. Some core guideline rules. So it's a core guidelines document, and they call each guideline, they call a rule. They are neither a guideline nor a rule. They explicitly state for the LNL section, naming and layout suggestions. These rules are suggested defaults to follow. So they're suggestions, not guidelines. So to follow unless you have reasons not to. So basically, you can use this. If you have no idea about what to do, then this is a good thing to start, a good point to start, but it's not really a guideline that you should just take at face value and adapt to your projects. The consistent part one, definitely, or conventional const notation. Look at what your code base has. If you work from scratch, ask your team and maybe pick the majority or whatever. But don't just blindly adapt these guidelines. In addition, where we put the const can be done by automatic tooling. This is what Clang format is for. You can tell Clang format, please put the const on this side, that side, or leave it as it is. Yes? Sometimes you're forced by the language to be easy. So then you just have to... Yes. So the east const, west const only works for if you have like a single type variable, not a pointer, not a reference, something like that, where you can say, okay, this is a const int or an int const, right? If you have a int pointer and the pointer has to be const, then you have to put the const on the right side anyway. And this is where the argument comes, well, actually east const is the more consistent one, because then it's every time on the right of, except when, okay, west const is something for the break, I guess. So if we have tooling, if we have Clang format that does this stuff for us, why do we need it in our document? Just put it out of the document, configure your Clang format, and it will do stuff for you. So please don't make me read formatting rules. Give me a Clang format file and it does everything it needs to do. Another guideline found in the wild. I think I have to. No, I'm good in time. Use Singleton for objects that exist only once. Facepalm. I know. Where does this come from? I actually found a screen grab somewhere in the archive of the first edition of the object-oriented design patterns of the Gang of Four book, where it says, this singleton design pattern, the intent is to ensure a class has only one instance and provide a global point of access to it. Again, two things together, not only has only one instance. A global variable makes an object accessible, but it doesn't keep you from instantiating multiple objects. So you want to avoid having the global and then have like local other objects of the same type, because usually you want to use a global in that case, right? Use when there must be exactly one instance of a class and it must be accessible to clients from a well-known access point. So like the order in which they write the well-known access point, the global one, and the one instance stresses a bit the one instance, right? But still, it's not the same as use singletons for objects that exist only once. This is like leaving out the major part, the global part. What's the impact of this? Previous projects ages ago, or like a decade ago. We had a code base where we had hundreds. I think it was like between 900 and 1200 singletons in our code base. It was a complete monolith that you could not decouple. When we wrote a unit test for one of our upper layer classes, the unit test would then take this part, and this would then have a reference to that singleton, which would have a reference to all these database access singletons, which would have like, and in the end we would have roughly 1.5 million lines of code tied into each single unit test, into each single class that had to be linked against that class because it was all tied together, plus a 180 megabyte access database that had to be linked into the stuff every time. Interpretation matters. So the thing about the singleton is this text has to interpret it, and the interpretations change over time. There is an interview with the Gang of Four authors like 10 years after they wrote that book, where they say, well, the singleton in itself is a good pattern, but how people interpret this part of the book went completely wrong. It's not how we intended it to go. So we have to get a common understanding. And the modern interpretation is, if you need global state, which you should avoid, you cannot always avoid it. If you actually need it, so turn this thing around. If we need this single access, then we should use singleton to avoid copies and multiple instances and stuff like that. But only if we actually need the global. Then the singleton is a good pattern. Not if we need something only once. An alternative to global state is dependency injection, but in large code bases, it can happen that you inject something up here just to trickle it down to 20 layers or something to just use it down there. And in that case, you have things especially in other languages like Java frameworks, C# frameworks, where you have like inversion of control containers and stuff like that, where you have like one big singleton container where it says, okay, if you want to have here something repository, ask this inversion of control container that is a singleton and it will tell you where this repository is and stuff like that. I haven't seen this kind of library, this kind of stuff in C++ code yet, but there might be. So this guideline use singletons for objects that exist only once. Don't do that unless for very good reasons. When you have a global that you can't get around, then it's the right pattern to use here. But definitely not 900 or 1200 times in one application. Let's get to guidelines about guidelines. So important is that basically everybody in the team should understand the context of your guidelines, the context you are working in, and the reasons why these guidelines are in the project, why you want to stick to those guidelines. Or at least observe the guidelines and then decide to maybe or maybe not stick to them. When do they apply? When do they not apply? Why are they actually important for your project? Some guidelines, well, yeah, they make sense, but if you do it or don't do it, we don't use this kind of code in our project anyway, so why should we adopt the guideline? Seek a common understanding how to break them, when to break them, and especially how to break them. So write explanatory comments. Have maybe in your guideline document, we follow the rule of 5 except for this or that case. Common case is when you have interface classes that contain no data members, so copying, moving, assignment is just a no-op, but you have to define the destructor of those classes to be virtual. And if that's the only thing, I have my virtual destructor defaulted, and I have no data members because my class is just an interface with a bunch of pure virtual methods, then that can be an exception that is not in the core guidelines document, where you can say, okay, in this case, we can just break the rule of 5 because everybody knows this is an interface. Maybe you have even a naming convention with a capital I in the beginning, which is, I think, horrible, but you can use it. Or call it something interface to make it more explicit. And then it's completely okay to break this rule because everybody knows, okay, this is an interface, I have a virtual destructor and nothing else. Naming conventions. Your services that don't need to observe this rule about references and stuff like that. Give them specific names, and if a class has a specific name, then nobody will tell you to remove the reference or remove the const and stuff like that. Concentrate on writing the guidelines that you can't automate, because if you can automate them, then hopefully your tool will helpfully point you at, yes, you have broken core guideline numbers 76 or something like that. And then you can look it up and get the documentation. You don't have to repeat that documentation in your guideline document. Automated tooling is your friend. I've mentioned Clang Format. I've mentioned Clang Tidy. Use static analysis tools, whatever you have, to give you all the warnings, so people don't have to look to in the code reviews to your code and say, well, you put this const on the wrong side of a variable, because that is a waste of time for everyone who has to review your code. If your automated tooling can do this in a fraction of seconds for you, right? However, using automatic tooling, they will tell us what's wrong. They won't tell us necessarily what's right. In many cases, they can fix it automatically, like Clang format. In many cases, Clang tidy has automated fixes for a bunch of the warnings that it emits. But if we have a warning that we can't automatically get fixed, we have to start thinking. Because sometimes we can just turn the warning off, project-wide or in a subdirectory or just on a line-by-line case. Sometimes not ignoring the warning and fixing the code is the right thing. How to fix a code is a completely different project. Definitely don't trick your tooling, like obfuscate the code so much that the tool can figure out while it's in principle does the same stuff, right? Try to actually fix the code. And this is just an example for the repository thing. There is a something core guidelines, ref data members, const or ref data members. I don't know the exact name. If you turn it on, then it will warn you on this repository reference, and then you can say // no-lint and tell Clang tidy this line, don't warn me about this ref data member thing, everything else you will still warn about. So you can configure your tools on a line-by-line basis. You can also tell it like, from this line start to this line end, please ignore all these warnings about C++ core guidelines or something like that. So know your tooling, know how to turn off these warnings. Because the one thing that I think we all should adapt as a rule, your code should not emit on any warnings, compiler warnings or tool warnings or otherwise. So guidelines mean freedom, mean responsibility. We can't just turn off our brain and let the tools do everything for us, right? So because they're guidelines, they're not rules. And please don't play the metrics. I've seen guidelines that say, okay, our functions shouldn't be too long. So we configure SonarQube or similar tools that give us a warning when the function is longer than 40 lines of code. I have seen people then go ahead and say, okay, I have two doubles initialized here. I just write double x, comma y, and I have only one line less. No more warnings. Or this function has 60 lines of code. Okay, I write two new functions, f part 1, f part 2, and I call them just consecutively. Not a good idea. So this is playing the metrics, right? Just hiding the fact that I wrote an actually too long function. And there are things like refactoring that you can do, split the function up and do things that actually make sense instead of just tricking the tools into shutting up. We should talk about guidelines and code reviews. There will be code that everybody reviews that violates some guidelines. Because nobody is perfect, we forget or we don't see that we violate a guideline, so we will have to talk about it. It might be a mistake, an actual mistake, to point out this violates this guideline. Did you do this on purpose? If yes, why? Or if not, then please fix it. It might be on purpose and justified, and then please add like your comment or whatever you agreed on, write down why you're violating guideline X and Y. Or it might not be justifiable, then you have to talk about alternatives. Why was the guideline violated here? What were you trying to achieve? How can you actually achieve it without violating the guidelines? So talking points and code reviews. Violating guidelines, not const on the left or on the right, right? And find the correct way to address the violation. About those guidelines. The guideline document that you use in your team should be short and readable and accessible. Nobody will read and remember a 30, 40, 50 pages of guidelines. Trust me, I've tried. Nobody will do it. They will know like the 5 or 6 key takeaways and everything else is ignored. nobody will find your guideline if you hide it away somewhere in a SharePoint or something else. So make it accessible. Have your onboarding document for the team, so everybody who goes on the team or is longer on the team has a usual references. We had projects where we actually had a pull request template where when you created a new pull request, it said, these are the guidelines that we follow. So before inviting anyone to review your pull request, you could have a look at the link and check, okay, these guidelines were the ones that I was thinking about. I followed them in the code. Now I can have everybody else review those. As I said earlier, references over petition, so include links to, we follow these C++ core guideline 1, 2, 3, 4, 5, and have links instead of just copy pasting them because it makes your document longer, right? Think about your team's situation, not only about the project, but about the experience and knowledge. The software landscape surrounding you. So depending on what libraries you use, you may want to adopt specific guidelines for those libraries, for the use of those libraries. Or maybe even specific about your project. We have in the project I'm currently working on a bit of a peculiar way to include Qt, and there's like certain patterns that emerge that the views can be null pointers and stuff like that, and we have guidelines how to explicitly deal with those null pointers because there are different ways to deal with them, and we want to have them unified to be on the safe side. One example, the rule of zeros, rule of 5 is something that becomes familiar rather quickly, I think. Do you need those in your guideline document? If you have people who have never seen those rules, probably you need them. If you have people who are familiar with those rules, everyone on the team is familiar with those rules, why would you include them in your guideline document? If you agree to exceptions, where you say, okay, we have this rule, but this is an exception, for example, the interface for the rule of 0, then maybe you should reference them in your guideline document. It's a living document, so it has to evolve. Talk about the content regularly. Have meetings regularly, maybe once a month, every other month, or maybe once a week, who knows. And check whether those guidelines still apply, whether some of these guidelines may be outdated after some time, or whether you have to adopt new guidelines. Sometimes I see in code reviews, well, this is a bit weird. Why did we do it this way? Maybe because we had a guideline, or maybe because we did not have a guideline to follow. And then we have to talk about them first in the code review with the other person, and then in our dev things where we say, okay, maybe we should adopt a new guideline, or maybe we should scratch the old guideline because it is not applicable anymore. Like, after 2 years, do you still need the rule of 0 or 5? I would not throw them away completely because you will have new joiners on the project, probably if it's a longer project. And then those new joiners will want to have a look at the guideline that you implicitly follow because you already know them by heart. And then they're grateful to see this archive, which needs to be maintained at some point. What about guidelines by customers? As I said, we are a contractor company. We work exclusively with customers, so we don't write our own products or something like that. Extra proverb for you. The customer is always right in matters of taste. If you're working for customers and they say, okay, we have these guidelines for you, they didn't hire you to follow their guidelines. They did hire you to actually write code for them. So that means you are probably the expert in writing that code and not the customers, else they wouldn't have hired you, more or less, right? So if you are the expert, if they buy your expertise to write code, then they might also buy a bit of your expertise to actually consult, do some consulting work for them and challenge their guidelines and maybe change the guidelines, because early return is something good and not something to be omitted. You may have different teams. I guess you have different teams. You may have very different situations. So if there are things not in matters of taste that you agree or disagree with, Other questions, comments, anything you want to add, or where you want to say, well, I'm not Google, but we want to work like Google. Anyone? Okay. Then thank you very much.